Assalamualaikum warahmatullahi wabarakatuh. Okay, this is part number 3, flexibility method beam analysis. So we are going to analyze this beam. Okay, so in the previous video, I have explained about how we choose the redundant and draw the primary system. And then about the compatibility equation, we solve the redundant using compatibility equation. Okay, and and from the redundant chosen, from the redundant chosen, I have also explained how we write the compatibility equation, which is actually based on the displacement at the redundant position. Okay, so I have chosen CY as the redundant. So the displacement, if CY is the redundant, so we have to determine the vertical displacement or the deflection at position C. So from principle of superposition, so we will determine displacement at C position in primary beam, in redundant beam, in order to solve for the redundant. Okay, so delta C naught plus FCC, delta C naught plus FCC times CY is equal to 0. 0 means there is no movement, there is no vertical deflection, vertical displacement in original beam, because of the support. There is a support, the roller support at C in original system, in actual system. So looking at this formula, this equation, delta C naught and FCC both are displacement. One is located in primary system, and another one is located in redundant system. So since the redundant is located at C position, means that we have to look at the two displacement, the two displacement, one in primary beam and one in redundant beam. So from the formula to calculate displacement, delta C naught, we will calculate by doing integration. We will integrate two moment equation, MC and M naught, and for FCC we will integrate MC and MC. Okay, so from this formula, we actually will write the moment equation. We will analyze two system. We will analyze two systems. System number one is called as primary beam or primary structure. Okay, M naught is actually the moment equation in primary structure, and MC or M1. We can choose either one. We can use either one, either MC or M1 as the redundant, as the moment equation in redundant system, in redundant beam. Okay, so we will start with analysis of primary beam. We will start with analysis of primary beam. Analysis of primary beam. Analysis of primary beam. So we will have, okay, we have the triangular load like this. We have point load and moment. So in the primary beam, we have to remain all external loading. Okay, so it is 50, 350, and 200. 50, 350, and 200. So the distance is 2, 3 meter, and 2 meter. Okay, so at A, AY, and M This is MA. And of course, AX is 0. So this is primary beam. From primary beam, we will get M naught. We will write the moment equation for primary beam and we label as M naught. So this M naught will be used in this formula, displacement formula, delta C naught. Okay, so looking at this, we have to calculate the reaction at the support, reaction at, because this is cantilever beam. This is cantilever beam, so reaction is AX, AY, and MA. And of course, AX is equal to 0. And from this, we have to calculate AY and MA. We have to calculate AY and MA. Okay, so let's calculate AY, the value for AY and the value for MA. Okay, for AY value, so we will use summation Fy is equivalent to 0. Summation Fy is equivalent to 0. So it is okay. If it is triangular, the area of triangular is representing the force in kilonewton. The area means that we have 0.5 times 2 times 2 times 50. Okay, so we have 0.5. The area is 0.5 times 2 times 50, and we have to plus by 200. 0.5 times 2 times 50, the answer is 50 lah, 50. And we have to plus with 200, so it is 250. So AY is 250. AY is 250. AY is 250. Okay, what about MA? MA is moment, taking moment at A, we will calculate MA. So to calculate MA, so from this it is negative MA plus the area 1 over 2 times 2 times 50. The distance is 2/3, 2 over 3 times 2. Okay, times 2, we have to plus with 350 and plus with 200 times 7. And this is equal to 0. Okay, so from this we will get, okay, 1 over 2 times 2 times 50 times 2 over 3 times 2. Okay, plus by 350. Okay, plus by 200 times 7, it is 1816.667. So MA is 1816.667 kilonewton meter, and it is positive. Okay, a positive value of MA means the assumed direction of moment is correct. So this is 1816.667. Positive means the assumed direction is correct. Okay, so this is actually the beam that we are going to use to write the moment equation. Okay, and now we will move to redundant beam. This is A, B, C, and D. Okay, now we move to redundant beam. This is MC. Okay, we can also use M1 for redundant. Okay, both can be used. Okay, so we have the beam A, B, C, and D. Okay, CY means redundant CY applied. Redundant beam means this is a beam which is subjected to a unit value of redundant. A unit value of redundant. A unit value of redundant. So we calculate, we have to calculate reaction. Okay, we calculate reaction and we get this one is like this, one negative, one positive. And for the moment, so it is like this. Okay, so this is the MA value and AY value for redundant beam. Redundant beam. Okay, so normally we calculate reaction because when we want to write moment equation, we have to have reaction. We have to use reaction. Okay. Okay, now we want to write moment equation, and the some summary of the moment equation we will put into the table. Okay, so looking at the primary beam, there are three cutting section: AB, BC, and CD. AB, BC, and CD. So this is one cutting section, two cutting section, three cutting section, three cutting section. And we have to do the same for redundant beam. 1, 2, 3. So this we produce one table. So in the table we have to list all the members. Okay, all the members. Origin that we use, and then limit means x distance. Okay, we have M naught is moment equation in the primary beam, and then we have MC, the moment equation in redundant beam. Okay, like this. Okay, we have member AB, we have member BC, and member CD. Okay, origin. For AB, origin we choose A. Okay, for AB, origin we choose A. But for BC, I don't want to choose A as origin because of the triangular load. Okay, normally we will choose the origin which give us the easiest cutting section. So for C, for BC, I would like to choose C as origin. I can choose either C or D. Okay, let's say this time I want to choose C as origin. So origin is C, and for CD origin is D. Okay, for the limit, if okay, the origin is A, means this is A. So the limit is 0 to 3. If origin is A and A is and for member AB there is A, so dalam AB tu ada A, origin kita A dan AB tu ada A dekat situ. Okay, so we can start the limit start from 0. Start from 0 means that at A x is 0. At A x is 0. Okay, for BC, if I choose C as origin, since C in BC there is C. So again, so if this C, if origin is C and C tu pada B member BC dia ada C, means C tu dia 0. So here we will have 0 to 2. 0 to 2. Because C ni dia ada pada BC. Kalau D as origin but we write moment equation for member BC. So in that case, limit is not 0. It's not started with 0. Okay, CD and D is origin. Again, it is from 0. From 0. 2, 3, 2. 2, 3, 2. Okay, because this is C, start from 0. Start from 0. This is D, start from 0. A, start from 0. Okay, now we will write the moment equation for member AB origin A. Member AB origin A look like this. 250. The moment is like this. Okay, and please remember when we cut section, the value here is not 50. It's not 50 because we have to compare this true triangular. Okay, so here is 2 meter and 50. And now if it is x, so what should be the value? It is 50. It is 25x. Means that when we substitute x is equal to 2 into 25x, we will get back 50. So here is 25x. 25x. It is interpolation. It is interpolation. Okay. So from this, we will write the moment equation. The moment equation for member AB origin A. Member AB origin A. The moment is 1816.667. 1816.667. Okay. Okay, now we are going to write the moment equation. The moment equation. Okay. And by taking moment at the cutting point is equal to 0. So what we get is negative m naught plus 250x. 250x. We minus by 1816.667. We minus also by, okay, the force is the area, 1/2 times x, because this is x, times 25x. This is the area. And the distance is 1/3 times x. 1/3 times x, and okay, 250x. Okay, so this is equal to 0. So we get m naught is equal to 250x. 250x. We minus by 1816.667. 1816.667. Okay, we minus also 4.167 x cubed. X 1 2 x square. Oh, x cubed. 1x, 2x, 1, 2, 3, x cubed. Okay, so it is 25 divided by 6. 25 divided by 6, we get 4.167 x cubed. So this equation we put into the table. So for m naught, it is 25x minus 1816.667, and we minus by 4.167. We minus by 4.167 x cubed. Okay. Okay, for member CD, we will do member CD first. So for member CD, what we get, okay, is this. And this is equal to negative 200x. Okay, because the moment is acting this direction. This is M. So M plus 200x equal to 0. So it is 200, negative 200x. Negative 200x. So this is negative 200x. Okay, what about member BC? So for member BC, so we have this 200. This is A, this is C, and D. Okay, the moment like this. The moment, and here is 350. Okay, origin at C means X is this. That's what it means, origin at C. Origin at C means X start from C. Okay, C to D is 3 meter. So we have to write the moment equation for this beam. Okay, so by taking moment at the cutting point is 0, then M naught plus 350, M naught plus 350, we have to plus with 200 times 3 plus X. 3 plus X. Okay, and then M naught is equal to negative 350, 200 times 3 is 600, 600 plus 350, it is negative 950. Okay, we minus by 200x. We minus by 200x, negative 950, negative 950. Negative 200x. X. So this is how we actually calculate the member forces. Member forces for primary beam. Okay, for primary beam. So for the primary beam, it is quite okay, complicated because of the loading. So we have to solve this first. For the redundant system, I don't think you have problem in writing the right moment equation. Okay, so I will stop now. We will continue with video number 4. So in video number 4, I will complete all the moment equation inside the table M0 and MC, and we will focus on how to calculate the redundant forces CY, and then how we determine from CY how we determine the remaining reaction at support A, MA, AX as well as AY. Okay, so I think that's all for this session. So we will meet again inshallah in the next video. Thank you very much.